I'm going to have to leave my headset on at a low volume because I actually recorded a video and somehow it did not record the audio. I don't know how I managed to do that. So now I have to remember everything I said. Oh, brother. I'm not going to be able to, so this is going to be a very short video. So I added a neon bulb. Oh, now, first of all, my prior circuit alteration by increasing the frequency to 100 kilohertz using a duty cycle of 10 microseconds was not a correction as I thought. It was simply faster. I simply multiplied the number of divisions on the commutator beyond the, maybe we could say, standard quantity of 20 divisions, 20 duty cycles per RPM, to a much higher figure, giving a much shorter duration of 10 microseconds as opposed to, if I can find it, as opposed to 20 millisecond duration. See, here's the 50 hertz, and I have 20 milliseconds. But look at this, I have 1 gigavolt coming in here. So just by increasing the speed, I increased efficiency by lowering the amount of voltage and the inductance on the coil that I had to inject, or I should say, simulate as a rotating magnetic field. So when I get up to, or get down to 10 microseconds, I'm able to use only 300 millivolts and get away with it, and 1 nano Henry and get away with it. But it gets better. If I add a neon bulb to the situation, now I can use 1,000 times less than not using it at this frequency, a mere 255 microvolts and 700 picohenries. A slight improvement on the inductance, but a very vast difference on the voltage. And so the net result is that the power from the rotating magnetic field to contribute to the coil winding need only be around 8 watts instead of what it was previously. If I can find it. Well, that was it, wasn't it? Yeah. Over 14 megawatts without the neon bulb. Everything else being somewhat the same, other than, tailoring this capacitor and this inductance of the rotating magnetic field to be the most efficient possible for everything else, all the other parameters. So I tweak these values to take advantage of whatever level of efficiency I can maximally get out of the simulation. But here, with this simulation, I call it a spark gap. It's really a neon bulb. Anyway, I didn't change that. I didn't change the... oh well, at least I changed this part in here. So I'm able to increase efficiency and still get negative current on the battery pack, indicating that the batteries are being recharged and they will never drain, and the thing will just keep running until the batteries age, die of the natural aging process that all batteries are victims of. But it will not die due to lack of voltage on the battery pack. It'll just keep running, like the Energizer Bunny. So some people would call that a perpetual motion machine, but I don't call it over unity or a perpetual motion machine, because unless I want to brag to the collective ignorance that most of us possess, but I know it's not over unity because I'm getting energy from a rotating magnetic field, which is equivalent to getting energy from the rotating magnetic field of an AC generator or a DC generator. Is there such a thing as a DC generator? Well, there's such a thing as a DC motor. There must be. So it's a rotating magnetic field, and I'm assuming that a magnet has a north pole and a south pole at its two ends, and so if rotating, should give an AC sine wave to the coil by way of a tight coupling. Now, I could only do this modification with a neon bulb using a tight coupling, and I will explain how I think we can provide a tight coupling and not worry about the potential possibility that or the possibility, that's an oxymoron, potential possibility, the possibility that this arrangement may be a loose coupling. And the way we get out of that is by taking Vinny's advice. Now, Jeffrey Miller, on his website, energybat.com, that's energybat.com, he says he uses an iron core to his coil winding, and he puts one slit down the side of that core to reduce eddy currents in this iron bobbin, we can call it, that he wraps the coil around. Iron is good, but we develop eddy currents, and so he has to put a slit there to stop or reduce that from happening. Now I go further. Now Jeffrey Miller was the first and possibly the only person who has ever been licensed to replicate Newman's device and sell it for a profit. Sorry. Oh God. Oh boy. Losing my voice. I've been talking. Well, this is my second recording. Oh my God. Is that better? Oh yeah, I can talk now. So this was back in the 60s when Jeffrey Miller was working with Newman. So he's like a living legend in terms of replicating Newman, because he's added all these refinements of his own to improve efficiency. Well, I've added a few of my own because I understand from watching YouTube videos, not on over unity devices, but simply how does magnetism exit a magnetized piece of metal such as iron. It never leaves from the smooth surfaces. It always leaves from edges, ridges, anything with striations. And if it's grooves, such as a circular groove of a metallic screw, it avoids leaving the shaft of the screw in the valleys between the ridges of the grooves that surround the screw. Instead, it congregates. The exiting of the magnetic field congregates at leaving that piece of iron at the edges of the grooves, and especially the tip, the pointed tip. So this is kind of like an ion generator in which you have negative ions or positive ions coming off of sharp edges. The same thing happens with a magnetic field coming from a magnetizable object or a permanent magnet for that matter. And this was done by putting a metal screw, a flat head screw, upside down with its head in a pool of ferro fluid. And then the pan that this was sitting in was, I think, plastic or glass. It might have been glass. And then underneath that was an electromagnet. And as the magnetic field was boosted and slowly increased, the ferro fluid would inch its way up the screw and eventually get to the tip and build up there without falling off, and build up along the edges of the grooves without falling off. And the valleys were vacant of ferrofluid. It had nothing there. So that taught me how magnetism comes out of metallic objects. So I envisioned that we're wasting magnetic flux if we don't do something about the ends of the bobbin, the iron magnetizable bobbin that the coil could be wrapped around. It's just going out into space instead of into the coil. So I envisioned that if we take a magnetizable iron cap to go over each end of the bobbin, and then the coil wrapping is right up against the edge of that cap, then the edges of the cap point directly into the coil, collecting the magnetic field coming out of both ends of the bobbin and redirecting it, because that's what all iron does. It doesn't shield. It simply redirects the geometry of the magnetic field surrounding that metallic object, and it redirects it back into the coil coming out of the edges, the circular edge, the round edge of this cap. Now, we could also put grooves on the outside of this tube, barring, the gap, down, sliced down one side of, once down the side of the tube, the bobbin. We can have striations or grooves going in a particular direction, either clockwise or counterclockwise. In this example, I do it counterclockwise. And then we wrap the wire around this metallic magnetizable bobbin in the same direction, counterclockwise in this case. Now, in order to get the simulation to be emulated in the real world, since now we're making improvements in the virtual world of simulation and then trying to translate that into real world design, you notice here that I have the two coils, the fictional coil of the rotor, the rotating magnetic field, versus the real coil of Newman's device. The polarity is swapped. And it only worked with it being swapped. If I tried to make them the same, it didn't work. So from the beginning, I've used swapped fields. Now in real life, we wouldn't have that happen readily unless we add a coil to the magnet, wound in the opposite direction, in this case clockwise, with its own grooves on the outside of that bar magnet, also in a clockwise screw-like direction around that bar magnet, and a cap, either, well, probably a non-magnetized cap, but a magnetizable cap that can get charged up with all of the field exiting the two ends of the bar magnet and collected into the cap and redirected into this coil that's wound around the bar magnet. Now the coil would either be just simply connected to itself or would have a resistor but still be isolated from everything else connected to itself in any case, whether we put a resistor in there or not. I don't know if we need one, but maybe we do. Maybe we need, we could put a negative resistor in the form of a neon bulb in there and it would work even better. So we could have two places to put a neon bulb. I didn't think of this before. Actually, well, no, that might work. That's right, I didn't simulate this coil around the magnet. I'm proposing it, I'm describing it to you, but I didn't simulate it. I should have simulated it. So if I would have simulated it, I would have put another coil up alongside this L2 and given it a tight coupling value of 1, and I would have made it very, very small, I don't know what, and it would have looped to itself, and then I would have seen, if it helps any, to put a neon bulb as the, some people call it a dark resistor. That's nice. I like that, dark resistor, instead of saying a negative resistor, because, you know, there's a reciprocal resistor, there's a negative resistor. In theory, you know, there's such a thing as a distinguishment between the two. At least I've made that distinction. So I like the fact that somebody online decided to call it a dark resistance, which helps clear the air. What's that? And then you got to get the straight dope about what that means and not get confused. And it's very interesting how, now that I've got these values reduced so severely on the magnet, the battery pack and its chopping mechanism of S1 and S2, well, it's not called S2, is it? Oh, here it is, yeah, S2, representing the commutator, creating this waveform, is now going all the way back and influencing the rotating magnetic field, which normally would be a sine wave. Just like this, the voltage on the rotor is a sine wave, but everything else past that, such as the current on the rotating magnetic field and everything else below that here, moving towards the battery, becomes less and less of a sine wave. Especially the voltage on the coil is a step up to a plateau. And I don't think we see it here, but there's, oh, I see, yeah, there's just one spike here on this particular plateau that goes in the opposite direction on the wattage, the power of the coil. And it never happens again. It's really bizarre. It happens just shy of the 60 microsecond mark. A duty cycle is 10 microseconds. That's listed down here and up here. So I don't know why this spike occurs, but it never happens again. And the longer you run this for, the more that spike averages into the total length of all these cycles, reducing the gain. In this case, it's a negative gain, helping to charge up the battery pack. But it doesn't change a whole lot as you lengthen your simulator time beyond 200 microseconds. So I just left it at 200 microseconds for efficiency's sake. You know, it takes less time to simulate this. particular circuit this way rather than running it for a second or 10 seconds. It takes a little longer without much benefit of accuracy, so I leave that alone. What else? I think that's everything. Yeah, so I tried a loose coupling and it didn't work. And then LTSpice would not allow me to do something different, a variation. Have only a tight coupling between the neon bulb that I had self-looped with itself, connected to, wrapped around L1, and then a loose coupling between L2 and L1. And it didn't work. LTSpice didn't let me do that. That would have been the preferable way to do this. But as I've already seen or shown in this example, the neon bulb works more efficiently when it's placed in line with the short, the self-short that the coil goes through for 20%, the last 20% of its duty cycle, except that I don't put it above the capacitor that would be only for 20%. I put it below the capacitor, so it's 100% of the time the neon bulb is there to give its benefit and thus give more. Then by comparison, if it were up here above the capacitor, it would only give its benefit 20% of the time instead of 100% of the time. So this is actually an improvement, putting it down here below the capacitor. Now if you don't have a capacitor here, if you don't have any capacitor at all across the coil, then you're only going to get the benefit of the neon bulb for 20% of each duty cycle. So it actually pays to put a capacitor in here in this position, whether or not you use 10 microfarads on the capacitor or not, simply for the benefit of the neon bulb alone. Now it will make a difference what capacitance you put on the capacitor, because that'll modify the output. The capacitor and the value of this inductance of the rotating magnetic field, they both influence the output, along with, of course, the voltage that's feeding the rotating magnetic field. So those three factors are factors you have to play with and learn how to play with them. And I tend to forget what it is, and I have to go through the learning process all over again each time I do a new version to this circuit. But putting in the neon bulb in here actually helps a lot, as you can see. A gain of efficiency of 1,000 times less voltage being required to feed the rotating magnetic field. What else? So again, for emphasis, if anybody tells you you cannot get energy from a magnet, just tell them, okay, but let's move the magnet, and thus, according to Michael Faraday's law of induction, we have now created an induced current in any kind of piece of wire that's nearby inside that magnetic field. It could be a coiled piece of wire, such as the coil in Newman's device, L1 here. But a rotating magnetic field is the same thing, or similar, let's put it that way. It's similar to a magnetic field that just simply moves in a linear direction, in a straight line, except here we are rotating that magnetic field, which makes it more compact, for one thing, and we can put it inside the coil, which is what Newman does. But he didn't cap his coil, and he wrapped his coil around a fiberglass bobbin. He did not use iron, magnetizable iron, such as Geoffrey Miller made. That was one of his improvements that he made to Newman's device. So we can always add these extras, a neon bulb, increase the frequency, which Newman did suggest, by adding more divisions to the commutator. In fact, Tesla has a patent in which he uses a generator that he designed to run at 150 cycles per second and higher by using a disc that had striations on either side of it, and that was a magnetizable iron disc, and that served as the substitute for his iron core to his transformer, because that was the core. And then he had two pancake coils on either side, and the windings of that pancake coil duplicated the number of striations to the disc, I believe. Oh, no, it wasn't a pancake coil. It was, the striations came out of the center of the disc radially. And so the coil also came out from the center, looped around and came back in the next groove, the adjacent groove, and then went back out away from the center of that disc along the next groove adjacent to that. And so it zigzagged in and out along these radial grooves. And so he spun the disc and kept the coils stationary. And depending on how fast he spun the disc and how many radial grooves there were in it, along with the matching number of coils, the zigzag coil on either side, he could regulate the increase of the frequency of this AC generator. And of course, he had a commutator managing all of this. So it's a very interesting patent, and let's see if I can find it. I have it. This is no good. That's why I'm retaping this. Charge. Oh, here we go. Design characteristics of Tesla's generator, or special generator. So I'm referring to Tesla's... can we enlarge this? No, I guess not. Wait a minute. No, we can enlarge it. We just use the browser to do that. All right. So it's patent number 447921, March 10th, 1891. And I believe this is the one. So he's got his commutator on the outer edge here, and he's got the grooves. But the interesting part about this is the other. He's got these grooves on both sides of this disc. This is one side and this is the other side. And then if you look at the disc from its edge, oh, I see, the disc is stationary and it's the coils. No. Huh? Oh, he's got 3 discs. And the teeth, the edge of the teeth on one disc facing the inner disc is a north pole and the other is a south pole. And I think he inserts pieces of metal in this disc. Oh no, pieces of metal? Oh, these are the 2 discs that have the grooves in it, but the middle one is smooth and it has inserts. So it has a magnetizable insert, a radial one here, and then it has nothing here, and then it has one here. And so they're spaced, I believe, double the number of inserts per gap between any 2 adjacent ridges. I think that's what he said he did. Or 1.5. This one looks like 1.5. Well, yeah, 1.5, because that, yeah. Well, 3 pair, actually. Anywho, so this is the side. You know, you go to see the patent, you'll see what I mean. I'm trying to show you. Oopsie. I think that's it. So that's a good reference, that patent, because it shows that when you increase the frequency on an AC generator, you do get an improvement of performance. And this is not unlike an AC generator, except it's not AC, it's DC. Yet, well, DC coming from the battery pack, yet it is AC coming from the rotating bar magnet. And then it blends the AC with the DC. So it's a kind of interesting device, that what Newman's come up with. And then we can add all these extras, depending on how creative we are and how knowledgeable we are. My knowledge is limited. I only learn what I learn from other people. And then I think of, when I think of a situation that it applies, then, oh, okay, it looks like this applies. And the simulator validates my presumption that a neon bulb helps and increasing the frequency helps, which is what Newman said, but he never said about adding a neon bulb in line with the in this position here. He said, talking about a fluorescent tube that was isolated from the coil with a secondary wrapping around the primary wrapping, connected, this secondary wrapping connected to the fluorescent tube. Anyway, I think I've said enough. I think I might have even repeated myself a few times there.